Practice problem number 3, very similar to number 2. It's another actual MCAS question and asks us which of the following is an irrational number. So again, we need to focus on rational numbers, those that we can write as ratios or fractions. Irrationals are the numbers that can never be written as a ratio of two integers or as a fraction. So our 4 answer choices here are written on the whiteboard up here. We'll take a look at that right now. Which one cannot be written as a fraction? That is the irrational one. The square root of 0, we know, is actually equal to 0, because 0 squared would equal 0. And 0 could be written as a fraction 0 over 1, as any whole number can always be written as a fraction quickly. So that tells me that answer choice A is incorrect because it's a fractional number, it's rational. Answer choice B says the square root of 3. And I know that the square root of 1 is equal to 1, and the square root of 4 is equal to 2. So I'm pretty sure that this square root is some 1 point ... irrational number. I believe B is going to be irrational because this square root isn't one of our perfect square roots as we start thinking about that perfect square root table. And all the other square roots, 2, 3, 5, 6, 7, 8, they're going to be some of the irrational square roots. So the square root of 3, I believe, is our correct answer. Let's take a look at C and D. C says 1.36 repeating. We know any repeating decimal actually comes from the fractions. So 36 repeating actually comes from the fraction 36 over 99, which we could simplify even further. They're both divisible by 3, but if you did 36 over 99, that repeats as 3636. So this is a rational number. All repeating decimals are rational numbers. And all terminating decimals are definitely rational numbers because those can pretty easily be written as fractions. If you read this number correctly, negative 1900ths is how we pronounce this. And that tells you the fraction that can easily represent this terminating decimal. So every decimal that repeats with a pattern or stops is actually rational. Some square roots are rational, but this is an example of one of our non-perfect squares, one of our irrational numbers. Take a look at square root of 3. 1.73205, and it keeps going. So that's our irrational number.